Bismillahir Rahmanir Rahim. Hello students, welcome to another video. This is Hamza Noor from Aero Education Network, and in this video I'm going to discuss some past paper questions on Pulleys, International A-Level Edexcel Mechanics M1, and particularly we are covering some questions for chapter number 4, in which we have this subtopic particles connected by pulleys. Okay, so first of all, we have handout question number 3, which is GCE M1 January 2010, question number 6. So the question says that two particles A and B have masses 5m and km respectively, where k is less than 5, which means that particle A is heavier particle A is heavier as compared to B. So when the system will be released, so particle A will come down and B will go upwards. Okay. The particles are connected by a light inextensible string which passes over a smooth light fixed pulley, and the system is held at rest with the string taut, the hanging parts of the string vertical, and with A and B are at the same height above a horizontal plane, as you can see in figure 4. The system is released from rest. After release, A descends with acceleration g over 4. We already know this, that particle A is heavier as compared to B. So when the system will be released, so particle A will come down. Okay. And the acceleration is basically g over 4. So part A is saying that show that the tension in the string as A descends is 15 over 4 into mg. You need to show the tension in the string in an exact form in terms of m and g. So here we have the solution for part A. Okay. So these are basically the classwork notes which I have discussed with my students. These questions were discussed in the class. So I'm just recording some lectures in English for my YouTube channel. So here is a solution for part A. As you can see that I have marked the forces over here. Since the mass of particle A is 5m kg, okay, so the weight of the particle is 5 mg Newton, okay, which acts vertically downwards. And when I'm referring to this particle A, so the tension in the string is moving away from the particle A. Okay, the string is straight, obviously. Okay, and this basically tension is the pulling force. And here we have the mass of the particle B, which is km kg. Okay, so the weight of the particle B is kmg Newton. And here I'm referring to particle B, so the tension in the string is moving away from the particle B. And as we know that A is heavier as compared to B, so A will come down and B will go up. So this means that when we are considering this particle B, so the magnitude of this tension is basically more than the weight of particle B. So I've just mentioned this inequality, T is more than kmg. And in the same way, when the particle A will come down, so weight of the particle A will have a higher magnitude as compared to the tension in the string. Okay, you don't need to mention these inequalities. It's not compulsory to do so. But the purpose of mentioning these inequalities is that when we have 5 mg minus t, this will be equals to 5 ma. This will give us a positive value of acceleration, and only for that purpose I have mentioned this inequality over here. Okay, so the equation of motion for particle A would be 5 mg minus t is equals to 5 ma. All right, and in the same way, the equation of motion for particle B would be T minus kmg is equals to kma. But here in this case, we only need to consider the equation of motion for particle A, because when the equation of motion for particle B is considered, k is unknown over there. And we don't have enough information right now in order to find the value of k. The value of k will be found in part B by showing that first in part A that the tension in the string is 15 mg over 4. We are going to use the value for this tension in the string for particle B, and then we will find the value of k in part B. All right. Since the acceleration is given to us, which is g over 4, okay, so what I'm going to do, I'm going to just consider this particle A right now. For part A, we are just going to consider this particle A. So we have the equation of motion for particle A, which is 5 mg minus t is equals to 5 ma, and the acceleration is given to us, which is g over 4. So t will be equals to 5 mg minus 5 ma, and in place of a we are going to write g over 4. So we have found the exact value of t, which is 15 mg over 4. All right. So in this way we have attempted this part A. We need to leave our answer in terms of m and g. And now in part B we need to find the value of k. All right. And since we know that we have found the value of t in part A, we are going to use it for the equation of motion for particle B. Okay, so here we have part B over here. So as I mentioned earlier, when we were considering particle B, so particle B was going upwards, so T would be more than kmg. All right. So this essentially means that, when T minus kmg, this will give us a positive acceleration. Okay, so T minus kmg will be equals to kma. And in place of T, we will have 15 mg over 4. So 15 mg over 4 minus kmg is equals to km into g over 4. In place of acceleration, we have substituted g over 4 over here. So what I can do over here is that on both sides of the equation, I can take mg as common. Okay, so mg can be eliminated. So taking mg as common multiplied by 15 over 4 minus k, and this will be equals to mg into k over 4. So mg and mg got cancelled out, eliminated. So this means that 15 over 4 is equals to k over 4 plus k. So 15 over 4 is equals to 5k over 4. 4 and 4 got cancelled out. Therefore, k is equals to 15 over 5, which is equals to 3. So the value of k is equals to 3. So here was a working for part B. Now in part C, it says that state how you have used the information that the pulley is smooth. So here we have the basic assumption that the pulley is smooth. So it implies that the tension on either side of the pulley is same. We can say that the tension at particle A is the same as the tension in particle B. So it is basically an assumption in mechanics which we use. Okay, since the pulley is smooth, so it is a frictionless pulley. It will have no friction, so the tension magnitude will be the same on both sides of the pulley. So here we have mentioned our answer that the tension in the two parts of the string are same, or you can say that the tension at A is the same as the tension at B, or you can say that the tension is the same on either side of the pulley. So this is basically amongst our basic assumptions when we are dealing with the pulley questions. Okay, so whenever you are asked about a smooth pulley, you need to consistently answer your question in this way, meaning the magnitude of the tension is the same on either side of the pulley. After this, we have part B. So part D, sorry, part D. So before part D, we have some information that after descending for 1.2 seconds, the particle A reaches the plane. It is immediately brought to rest by the impact with the plane. The initial distance between B and the pulley is such that in the subsequent motion, B does not reach the pulley. Okay, because it says that when particle A hits the ground, in the subsequent motion, B does not reach the pulley. Otherwise, before the particle A comes to ground, B would, stuck at this point over here at the pulley. So here is basically the assumption which is given to you over here. All right. And it says that after descending for 1.2 seconds, particle A has reached the plane, has reached the horizontal plane, and it is immediately brought to rest by the impact with the plane. Okay, so in part D, we need to find the greatest height reached by B above the plane. All right, so as you already know that, as you are already aware of the concept of the slack in pulley, okay, so you need to be able to know all of the concepts, okay, before starting the past paper questions. So basically what happens is that when particle A hits the ground, okay, so particle B comes over here, and after this, there would be slack in the pulley. The string will not remain straight like this, a string will bend, and this basically motion is called the slack in the pulley. The connection of the string breaks with the pulley. And when we have slack in the pulley, so the tension in the string becomes zero. Okay, the magnitude of the tension becomes zero. So this motion is basically called the slack in the pulley. And I hope you have covered all of these basic concepts in the examples of the book and the questions of the exercise. Okay, so here is a solution for part D. So what we have is, first we have a journey which is before the slack. Okay, first we have before the slack journey, and we need to find how much distance particle A has covered when it hits the plane. It would be the same, you know, same value of distance which particle B will cover when it's moving with the motion of the pulley. When the particles are connected by the pulley, so we need to find the distance which particle B is covering over here. This journey is basically before the slack. It means that before the string loses the connection with the pulley. Okay, before the slack actually happens. So initially the system was held in rest. All right, so initial speed, initial velocity is equal to 0. Acceleration of the system was g over 4, which we already know this information from the question. Okay, and we need to find the distance in 1.2 seconds, because after 1.2 seconds, particle A hits the plane, hits the ground. Okay, so we need to find the distance. All right, so basically this whole working is for particle A as well and particle B as well, irrespective of the particles. Okay, if anyone sees this working, they won't be able to tell you that this complete working is for particle A or B. Okay, this complete working is for both the particles, because before the slack in the pulley there is connection of the particles with the string. Okay, and there is the connection with the pulley. So what's happening is that before the slack there is connection of the particles with the string and the pulley. All right, so here is the whole idea behind this. So S is equals to ut plus half at square. So u is 0, t is 1.2, and acceleration is g over 4. So we have found the distance in terms of g over here, which is 0.18 g meter. Okay, this is 0.18 g meter. And then we are also interested in finding the speed by which particle A hits the ground. It would be the same speed by which, particle B comes from this position to this position. Okay, because the final speed in before the slack journey will become the initial speed for after the slack in the journey. This makes sense. So obviously we are interested in finding the final speed over here as well. So V is equals to U plus AT. In place of U, I'm going to write 0. Okay, and acceleration is g over 4, and time is 1.2 seconds. So V is 0.3 g meter per second. So when slack in the pulley occurs, so particle B goes vertically under the motion of gravity. In that motion, basically acceleration due to gravity is minus g meter per second square. And what is the proof of this? If we consider the equation of motion for particle B. Okay, so basically when slack happens, so the tension in the string becomes 0. So T becomes 0. So in place of T, we write 0. So 0 minus 3 mg is equals to 3 ma. So this 3m got cancelled out, and acceleration is minus g. This piece of working is very basic. Okay, this is very basic thing over here, because after the slack happens, particle B goes vertically freely under the effect of gravity. It moves up. Okay, but in order to make you understand this thing, I've mentioned this equation, because this is a very basic case of pulley. When you deal with inclined planes, okay, so let's say if a pulley is fixed at an edge of an inclined plane, okay, and when the slack in the pulley happens, so you consider the equation of motion of this particle, and it depends also that this inclined plane is smooth or rough. So you consider the equation of motion of the particle according to the Newton's second law of motion, and then in that particular equation you put t is equal to 0. All right, so here we are dealing with a basic case of pulley. Okay, so I've just mentioned this equation over here. It's not compulsory to do so, by the way. It's only for your understanding. All right. So when basically the slack in the pulley happens, so now what happens is that the final speed of before the slack journey will become the initial speed for after the slack journey. When slack happens, so u will be equals to 0.3 g, and acceleration is minus g, and at the highest point above the ground, the final velocity of particle b will become zero, because after this particle B will change its path of motion and it will come down again. Particle B will change the direction of motion. So at the highest point above the ground, velocity will be zero, meaning its speed will be zero. This S, U, V, and A all are vector quantities basically. Okay, and we can get the values of the scalar quantities over here as well through these equations. This basic idea you have already studied in constant acceleration chapter. So T is not involved over here. We don't know what is the duration of this slack in the pulley journey. So T is not involved and we don't need the value of T over here. We have V square is equals to U square plus 2AS. Okay. So in place of V, I'm going to write 0. In place of U, I'm going to write 0.3 g, and acceleration is minus g. So S is unknown. So we are going to find the value of S. So I'm going to rearrange the equations, and then finally I get that the value of S, meaning the displacement, which is actually the distance over here, is 0.045 g meters. Therefore, we can say that the greatest height of particle B, okay, above the ground, above the plane, okay, basically when particle A hits the plane, it has covered a distance of 0.18 g meter. And since A and B are on the same horizontal line above the plane initially, so this implies the fact that particle B is also initially 0.18 g meter above the ground. Then after this, A covers 0.18 g meter towards down and B covers 0.18 g meter upwards. After this, slack in the pulley happens, and the distance of the slack in the pulley we have found. Okay, so altogether, these three values are going to be added over here. Therefore, we are going to say that the greatest height of particle B above the plane is 0.18 g plus 0.18 g plus 0.045 g. So when these three values are added together, we get 0.405 g meter. Either you can leave your answer in terms of g as well, or you can just evaluate the value correct to three significant figures. Okay, so here I've mentioned the value correct to 3SF, but remember you need to use a value of G which is equals to 9.8. Any other value of G is not acceptable in Edexcel M1. All right, so this is basically your answer. Either you can leave your answer in this form or in this form in this particular question. So this was basically the complete solution of this question. So now let's move forward. So after this, we have another question, which is handout question number 6, which is GCE M1 June 2010 question number 8. All right. So the question says that two particles A and B have mass 0.4 kg and 0.3 kg respectively. The particles are attached to the ends of a light inextensible string. The string passes over a small smooth pulley which is fixed above a horizontal floor. Both particles are held with the string taut at a height of 1 meter above the floor as shown in figure 3. The particles are released from rest, and in the subsequent motion B does not reach the pulley. Okay, so basically particle A is heavier as compared to particle B. So particle A will come down and B will go upwards. So the requirement of part A is to find the tension in the string immediately after the particles are released. Okay, so here is the solution for part A. First, I brought a screenshot over here and then I marked the forces. Okay, so the weight of the particle A is 0.4 g, weight of the particle B is 0.3 g, and when I'm referring to particle A, so the tension in the string is moving away from the particle A, and when I'm referring to particle B, so the tension in the string is moving away from the particle B. So here is the solution for part A. So basically particle A is coming down, so this 0.4 g will have a higher magnitude as compared to the tension in the string, and since particle B is going up, so the tension in the string would have a higher magnitude as compared to zero point 0.3 g. Okay, so 0.4 g minus t will be equals to 0.4 a. This will give us a positive value of acceleration. So equation of motion for particle A is 0.4 g minus t is equals to 0.4 a, and the equation of motion for particle B is t minus 0.3 g is equals to 0.3 a. So as you know that in part A we need to find the tension in the string, so we need to eliminate A over here, we need to eliminate acceleration over here. So when A is made the subject, so I've made these two equations and equated both of them with each other. Okay, so therefore we got the equation in terms of t. All right, and we were able to find the value of t in terms of g. So 0.24 g divided by zero point 0.7. Okay, so t is equals to 12 g over 35 newton, or you can just use the value of g over here and you can give your answer correct to three significant figures. In this particular question, in terms of g was not compulsory. Okay, it was not compulsory to mention the tension in the string in terms of g, so both are fine. Okay, my usual practice is to always first find in terms of g and then accordingly answer the question. Okay, even if it's not required in terms of g, it's good to use in terms of g first, and then you can write your value correct to three significant figures. In part B, it is asked to find the acceleration of the particle A immediately after the particles are released. Okay, because we need to find the acceleration of the system. Okay, the system by which particles are moving. So as we have found the value of t in part A, okay, and you can pick any of these two equations over here. All right, so acceleration is equals to t minus 0.3 g divided by zero point 0.3. All right, so acceleration is 12 g over 35 minus 0.3 g divided by zero point 0.3. Since both particles have the same acceleration, so it really does not matter which equation of motion you are using, since both of them are equal. Okay, so acceleration is equals to g over 7 meter per second square, or you can say 1.4 meter per second square by using the value of g in the question according to the Edexcel mechanics syllabus. All right, and then what happens is that we have part C. Here was a solution for part A and B completely. And in part C, I hope the picture of the question is clear. The pixels are fine, I believe. Okay. So basically before part C, it says that when the particles have been moving for zero point 0.5 seconds, the string breaks. Okay. Find the further time that elapses until B hits the floor. Okay. So basically what happens is that when particle A, comes down for zero point 0.5 seconds, particle B goes up, and immediately at this point, the string breaks, which you can also say that this is a similar case to the slack in the pulley, meaning the connection of the string is broken. It is cut now. Okay, so after the string is cut, particle B will freely fall on the horizontal plane, horizontal surface. Okay, it will come down freely under the motion of gravity. All right, so here is a solution for part C. So first thing first, what I did, before the string cuts, I wanted to find the speed of the particles. Okay, the speed of the particle A by which it comes at a point after a duration of zero point 0.5 seconds, which would be the same speed by which particle B comes over here after, you know, after the duration of zero point 0.5 seconds. So we are concerned about the first 0.5 seconds over here only. Okay, so before the string cuts, acceleration would be g over 7, which we have found in part B, and the system is released from rest. So initial speed, initial velocity would be 0, and time duration is 0.5 seconds. We want to find the speed over here. So v is equals to u plus 80. So v is equals to g over 14, or you can just simply say 0.7 meter per second. And now, after this, I have also found the distance by which, both particles have covered in the first 0.5 seconds. Okay, because we need to see what would be the height above the ground when the string cuts, and what would be the total distance that particle B would cover when it falls on the ground. So obviously I am interested in this distance as well, which is basically the same distance which particle A travels over here. Okay, and particle B comes over here, after which this string is cut over here. Okay, so this makes sense. So due to this reason, I want to find the distance over here. So I can use S is equals to half T into U plus V. We are concerned about the first 0.5 seconds only. Okay, and U is 0. And V we have already found, which is G over 14. So the distance covered is G over 56, or you can say 0.175 meter. All right, so now what I am going to see that, the total distance which particle B will cover when it falls on the ground. Okay, so the total distance would be 1 plus 0.175 meter. This makes sense or not? So the total distance over here is 1.175 meter. And here basically when particle B is falling under the motion of gravity, I have taken this downward direction as positive. So displacement would be positive 1.175 meter. Acceleration due to gravity would be g, okay, which I have used the value of g over here. And since I have taken the downward direction to be positive, initial velocity would be minus zero point 0.7, okay, because before the string cuts, you have found the speed over here, okay, the final speed over here, which will become the initial speed when the string is cut. But we are dealing with vector quantities, okay, and we have taken the downward direction to be positive, so initial velocity would be minus zero point 0.7. Okay, since when particle B was going up, okay, when particle B was going up, so the velocity over here was zero point 0.7. And now when particle B is coming down and we have taken the downward direction to be positive, so U is equals to minus zero point 0.7 meter per second over here. All right, this makes sense. Alternatively, you could have taken the upward direction to be positive as well, which I have mentioned on the next page. Okay, I'll just come to that. But here I have taken the downward direction to be positive. So you need to have the basic sense of the path which you are considering to be positive, either upwards or downwards. And I am hopeful that you have covered all of these basic concepts in constant acceleration chapter. Okay. Otherwise, if you are struggling, you can contact me in order to enroll in my online classes. It was just a shameless advertisement. By the way, I have taken the downward direction to be positive. So S is equals to ut plus half at square. So in place of displacement, we have 1.175 meter. Okay. And U is obviously minus zero point 0.7. T is unknown. Okay. So we are able to produce a quadratic equation over here in terms of T. All right. And then I've used the quadratic formula. And obviously, the positive value of t will be considered, and this value will be rejected since time is positive, time cannot be negative. Okay, so t is equals to 0.566 seconds. Correct to three significant figures is your answer. Our requirement was to find the further time that elapses until B hits the floor. The further time that elapses, after the string is cut, because after the particles traveled for zero point 0.5 seconds, a string was cut. It breaks. This means that the system of this pulley was very weak, huh? It was not strong enough to, you know, continue the particles traveling. So it was a weak system. All right, and after the system was released from rest and after zero point 0.5 seconds, the string breaks. So further time that elapses until B hits the floor is basically, the total duration which particle B has taken when it hits the floor. I mean, before hitting the floor. All right. So obviously this case is not exactly the same like when we consider the slack in the pulley in a usual scenario, just like uh, we have considered in the previous question. Okay, so the particle B will not go up after the slack in the pulley after the string is cut over here, okay, because A is not hitting the floor. When A would hit the floor, then particle B would go above for a while and it would go above under the effect of gravity. This would not be happening over here. Immediately after zero point 0.5 seconds, this string is cut. Okay, so here is your answer. Congratulations, here is your answer. T is equals to 0.566 seconds, correct to three significant figures. Alternatively, if I would have taken the upward direction to be positive, if I would have taken the upward direction to be positive, then displacement would be minus 1.175 meter and initial velocity would be zero point 0.7. Okay, and acceleration due to gravity would be minus g. And in this case, the acceleration value, which is minus g, which would indicate a negative value of acceleration, it would imply that the particle is accelerating in the opposite path. It's not actually deceleration, okay? It's not actually deceleration. So when the value of acceleration is negative, all of the time it does not mean that it is deceleration. Sometimes it is acceleration in the opposite direction as well. Okay, so this is basically the whole idea. And again, I'm saying that these all of the basic concepts should be covered in chapter number 2. And here we are discussing the past paper questions of chapter number 4 specifically. Okay, so you are going to get this quadratic equation, okay, which is basically the same one which you got above, and then you would be solving this quadratic equation and you would be able to get the value of t, which is 0.566 seconds, correct to three significant figures, which I have already found. All right, so this was basically the past paper question over here, which is handout question number 6. So for the sake of this video, I have discussed these two past paper questions. Inshallah, I'll be uploading more videos soon. I believe this is more effective that I, you know, completely show the classwork of my online classes in this way, which I have already solved. And I want to record lectures in English for my YouTube channel. So I believe this is the most effective way right now. In less time, I can make maximum videos, maximum lectures, and it would help students a lot as compared to the case where I solve the complete question from scratch for the recording in English. So I believe this is more effective way to do this. All right. So see you in my next video. Stay tuned to my channel. Thanks for watching.